For our last example in this section, we are going to be looking at a race. So 4 runners are running the mile: Maria, Aretha, Thelma, and Debbie. Points are awarded only to women who finish first or second. For the first gets more than the second for obvious reasons. And what we want to figure out is how many ways we can get arrangements of first place and second place. Now I'll say about this kind of problem, when we start talking about probabilities and counting later, we'll see that there's a much easier way to compute this. But for now, we're going to do it the longhand way, and we'll see that it's still not quite that bad. So the best thing to do here is think about how we can actually picture these results, because we've got a whole bunch of them we can count. And for me, I think the best way to do this is to try and diagram things. Try and see this as sort of something like what's called a decision tree. So we've got our 4 runners. Any of them can finish first. So let's see what happens if each of them finishes. So I'll say, let's think about what happens if Maria finishes first, or Aretha, or Thelma, or Debbie. Here's our 4 options for first place. Okay, if any of them finishes first, then what happens? Well, if Maria finishes first, then that means that one of these 3 and no one else come in second. So from here, 3 options spring out. Either Aretha, Thelma, or Debbie place, and then we don't care about any of the other options because they don't win anything. Think about an old movie. First place wins, second place is a set of steak knives, and who cares about the other 2? If Aretha comes in first, then we have Maria, Thelma, or Debbie as our options for second place, and I didn't give myself quite enough space here. That's fine. If Thelma wins, then it is either Maria, Aretha, or Debbie, and then finally, if Debbie wins, it would either be Maria, Aretha, or Thelma that win. The thing that we can see here is that for this, we have 3 options. Here, we have 3 options. Here we have 3, and on top we have 3. Because in each case, we only got 1 choice for who wins, and then 3 remaining options for who comes in second. So in total, we've got 3, 3, 3, and 3. 12 options. The big thing here was being able to recognize that in order to approach this problem, maybe a good way to look at it was diagramming it out, looking at it a bit more